Good morning friends. In this video, we are going to see complete fire pump room requirement based on NFPA. In addition to the NFPA requirement, I am going to provide some special requirement of factory mutual FM and also underwriters laboratory UL. And along with that one, we will discuss about the special requirement of UAE Fire and Life Safety Code, Qatar Civil Defense requirement also. So if you watch this video fully, you will get a very clear understanding of fire pump room. You can crack any interview also. So let's start the video. When coming to the fire pump room piping, we normally find these type of different piping. For example, coming to the tank side, we have the water supply filling line which is given to the tanks and balancing line between tanks. So that means we have two different compartments, compartment 1 and compartment 2 for the firefighting tank. So in between two compartments, we have to provide the balancing line. So the third one is a circulation line, and for example, if you see the UAE normally provide the circulation pump between two tanks. So that is a special requirement. And coming to the pump side, we have the pump suction line, we have the pump discharge line, and we will discuss about all these things very detailed. First, this is the introduction one, and we have the relief line from the diesel tank, and we have the testing line. Then we have the breaching inlet line to the discharge side. So we have the breaching inlet line coming from the fire department connection. Then diesel pump exhaust pipe with the cap connection, with the termination cap. And coming to the diesel tank, we have to provide diesel tank filling line to fill the diesel from outside. Then diesel tank vent pipe will be there, diesel tank drain connection. Then from diesel engine supply connection from the tank, that means from diesel tank to diesel engine, the supply connection. And additionally we have the return connection. Then in order to verify the fuel level, we have the fuel level switch connection. Then active fuel maintenance, the return connection. So these are the 7 connections related to diesel tank, and additionally these are the 9 connections for the fire pump tank and pump side. So let's discuss about each and everything very detailed. First, for this fire pump room in this project, I have is comes under the extra hazard 2, because we have the diesel tank. So because of the diesel tank, the fire pump room comes under extra hazard group 2. And if you see the density area curve from NFPA 13, and you can see for the extra hazard 2, I have followed 0.4 GPM per feet square density for the sprinkler. And if you go up, then you can see the area. And for the hydraulic area, I have to follow 2500 feet square hydraulic area I have to follow, and whatever the sprinkler comes in the hydraulic area I have to consider. But unfortunately, I have the fire pump room which has only the area of 495 square feet, so I have considered whatever I have. So the second thing, so 0.4 gallon per square feet I have considered. And coming to the sprinkler, type of sprinkler, so type of sprinkler I have followed only the standard response. I don't need the quick response sprinkler for this type of fire pump room, so I have followed the standard response. And K5.6, the normal one, I have followed for the fire pump room. And the sprinkler rating 68 degrees Celsius I have followed, so I don't need to go with the higher rating like 79 and higher, because this is a normal pump room. There is no special requirement like cooking and this thing. So then in that case I need to go with a higher temperature rating. So here it's like a 68 degrees Celsius normal sprinkler I have followed. And maximum sprinkler distance to the wall, that is like a half sprinkler to sprinkler spacing. That means for example, if you see this one, NFPA 13 requirement, so this is for the extra hazard. So extra hazard, the production area for the sprinkler must not exceed 100 feet square or 9 meters square, and maximum spacing between two sprinkler must be less than 12 feet and 3.7 meter. And this is between two sprinklers. This is between two sprinklers they have given. For example, if we have the wall, from the wall to the sprinkler we have to follow half of the maximum spacing. For example, here the distance between the two sprinklers is 3.7 meter, and from the sprinkler to the wall, that should be half of the maximum spacing. So that means 3.7 divided by 2. So that is the requirement I have followed for the spacing. And sprinkler coverage 100 square feet, as I mentioned here, I have taken the value from NFPA 13. Maximum sprinkler spacing 3.7 meter, that also I followed. So this one, you can see the density, it is more than 0.25 GPM per feet square. For this one I have referred, yes, of course, because we have extra Z2 where the density is 0.4, that's why I have referred this table. So coming to the first one, filling tank to the firefighting tank. So if you see in this drawing, you can see the yellow color line which is coming like this. which is coming from the outside from the water supply connection. So for the two compartment, this is compartment 1 and this is compartment 2. So for both compartments I have a separate filling line, and in the filling line like you see here, we must have the water meter to monitor how much amount of water is passing through the firefighting tank and irrigation tank, water supply tank, different tanks. So each tank must have the water meter line to monitor the water. And second thing, here in the filling line you must provide the isolation wall to isolate this connection, and this is the minimum requirement for the filling line. The filling line should come from the outside water supply connection. So this is the first one. So for the balancing line, you can see the connection here. So from here to here there is a balancing line. So it should have the one isolation wall to isolate this one. So from here normally what happen, we have two compartment for the firefighting tank. As you see here, we have compartment 1 here, compartment 2 here. Between two compartment we must provide the balancing line, and this is what happened here. And coming to the third line, it's a circulation line. So as I mentioned here, the circulation line between the tanks and pump. So normally this is the special requirement we follow in the UAE. So that is the concept here is we should have one circulation pump located here. From the circulation pump the line will go to the firefighting tank, and I mean both the tank, and also it will come back to the circulation pump. So this will be like a closed loop. It will circulate in this region between firefighting tank and firefighting circulation pump. So this is as I told you, is the additional requirement in the UAE. And there are few more items we have to discuss about the firefighting tank. That is, first you can see this project I have used the RCC concrete tank, so with the two apartments. So normally we can use RCC concrete tank and other GRP tank also. So as per NFA we can select the concrete material. So in the concrete tank you can see there are two water level indicator I have provided here. So inside will be water level indicator will be there to monitor the water level. Additionally the overflow pipe has to be provided. So if the tank is filled, I need to empty the tank, means like overflow line will normally come. So the overflow line for both the tank we have to provide. So additionally we have to provide the drain line. Drain line you can see this inside, like if I zoom here you can see this line. For example, here at this point from the bottom of the tank we have to provide the drain line. So like you see here, we have the drain line here for this tank 1 and tank 2. So both the drain line we have to provide here. And in the RCC tank we have provided the entry. So for both the tank we have provided the two entries from the side, and inside the tank you can see the anti-vortex plate. So anti-vortex plate has to be provided to avoid the turbulent flow, because we have two type of flow, laminar flow and turbulent flow. This turbulent flow must be avoided because this water is going to the fire pump. So in order to avoid this one, we have the anti-vortex plate. I have provided the anti-vortex plate. After that this line is coming directly to the fire pump. Now we will see the requirement of firefighting pumps. So when it comes to suction line, the first thing you can see the puddle flange. The puddle flange, this is the wall. So this is the concrete wall. So inside the concrete wall of the suction side, discharge side, the balancing line, everywhere, whatever the connection which is penetrating into this line, we have provided the puddle flanges. So puddle flange, you can see this line, which is the puddle flange, which is indicated here. And from the suction line, you can see at this point also this suction line. So here we have one OS and Y gate wall we have provided. OS and Y mean, you know, that outside screw and yoke. So that wall I have provided it here. By visually you can see the valve is open or closed. So that is the reason for the firefighting we normally provide the OS and Y gate wall. And coming to the suction line, so you can see here we have provided the OS and Y in the main header, suction header. After the suction head, we have three different pumps here. The first pump what you see in this one is like this is the diesel pump. After that, inside you can see this support and this pump. This is the jockey pump. And the third pump what you see here at this level, that is the electric pump. So we have electric pump, jockey pump, diesel pump, three combination here we have provided here. So first coming to the suction line, you can see here. So we have the OS and Y in the individual line, which is coming to individual pipeline, and we have the strainer here. We have provided the strainer here. Additionally, here you can see we have provided the reducer here. Normally we have two type of reducer: concentric reducer and eccentric reducer. The important difference between these two is, you can see in this image concentric reducer which has the shape like this. and with the reduced surface like this. And eccentric reducer, in the top it will be a straight line. So in this eccentric reducer we must use in the suction line, because normally the concentric reducer if you use, what will happen, there is a chance that the air will be trapped at this point. So to avoid the air trapping, in the top side we must have the flat surface. So this is the eccentric reducer normally allowed to use in the suction side. But coming to the discharge side, it's not an issue. You can use the concentric reducer or eccentric reducer, both you are allowed to use in the discharge side. In this section drawing, you can see for your clear understanding. So here we have provided the OS and Y gate wall. This is the main line wall. This is the main line header, OS and Y gate wall. And coming to the branches line to the individual pump. So first fire diesel pump, I have this. You can see the marking DFP. That means the diesel fire pump I have provided. So here first in the branches line, I have the OS and Y gate wall. After that we have the strainer, and after the strainer you can see the eccentric reducer I have given here 6 by 4 inch, because the pipeline is 6 inch, and for the fire pump connection it is 4 inch. So I have provided the eccentric reducer here. After that you can see the FC is the flexible connection I have provided here. Additionally we have the pressure gauges PG in the suction and discharge. Coming to the fire pump, here we have used the end suction top discharge pump. Normally you know that we have 4 type of pump for the fire pump as per the UL. So like the vertical turbine pump, end suction top discharge, vertical inline pump, and split case pump, horizontal split case pump. So in this project I have used the end suction top discharge because of the orientation, end suction top discharge, horizontal centrifugal pump I have used here. And here you can see I have given 2 gauges. And coming to the discharge side, again the flexible connection, the first one, to avoid the vibration transferring to the system, we have provided the flexible connector here. After that the reducer, like you see here, I have given the concentric reducer here, because as I told you we can use the concentric reducer in the discharge side, that is acceptable. Then we have the fire pump, the line which is going further. So we have the NRV valve means non-return valve or check valve. So the water should not come out to the pump after the discharge. So we are normally providing NRV, non-return valve, check valve. Then again we have the OS and Y gate valve in the discharge side. So in this image you can see very clear, you have a very clear view. So diesel pump, so we have the discharge line which is coming here. So we have the flexible connector reducer, and here we have the check valve and OS and Y gate valve. And before that you can see this line which is going like this. And here we have one special valve that is called as a relief valve, and this line is called as a relief line. This line has to go to 2 different tank like this. So the 2 different compartment it is going that. And this relief valve, how to size we can see now. This NFPA 20 we have to follow for the minimum pipe size. So for the minimum pipe size only we will follow this one. For the actual pipe size we have to perform the hydraulic calculation in the later stage. For example, in our project we are using the fire pump with the 500 GPM. So for the 500 GPM fire pump, the suction line, so it has to be 5-inch pipe, and the discharge line it has to be 5-inch pipe, and the relief valve, so what I showed you now, the relief valve, it has to be 3-inch relief valve, and the relief valve line must be 5-inch. So the relief valve should be 3-inch and relief valve line should be 5-inch. That means near to the relief valve we have to provide the reducer like that. And the meter device should be 5-inch. The meter device means it's a testing line. Testing line I will show you now, that should be 5-inch. So now we discuss about the complete suction requirement for the diesel pump and the discharge side, all the accessories, and additionally you can see this relief valve, also the relief line. So all this requirement for the diesel pump we discuss. Additionally we discuss about the filling line. Now we are going to the next valve, that is called as the jockey pump. So in the jockey pump we will see all the special requirement. So first coming to the top view, this is the top plan. So here you can see first this diesel engine we already discussed, and this is the relief valve and relief line which is going to 2 different tanks, that is also we discussed. And coming to the next pump, that's a jockey pump. So from the header, from this header you can see one line which is coming to this pump. This is called as a jockey pump, and this is connected with the discharge header. So in this line, for example, you can see the isolation valve we have provided. So the isolation valve is located here, and as per the rule that there is no need to provide the OS and Y valve for the jockey pump, because this is jockey pump is not a fire pump. Jockey pump is just a pressure maintenance pump, so we don't need to provide the OS and Y gate valve for this jockey pump particularly. You can provide the normal gate valve for the jockey pump, but coming to the fire pump, diesel pump and electric pump, you must provide OS and Y gate valve. So here we have provided the normal gate valve. After that we have the jockey pump, and it is connected with the discharge header. So again in the suction line we have the strainer and gate valve. In the discharge line we have the check wall and the gate wall. So this is connected with the discharge side of the header. So coming to the third one is a electric pump. So from the suction header we have taken the same line, and here in between you can see the OS and Y gate wall. Again we have the same arrangement. We have the reducer, we have the flexible connector, and this is the electric pump. Like the pump you can see here, electric pump, and in the discharge side we have the flexible connector, and additionally we have the check wall and gate wall. So you can see in the key plan also. So for example here you can see the same arrangement, and we have the connection like this, and we have here we have the OS and Y gate wall, and we have the reducer here is a eccentric reducer and flexible connector, and the pump, and in the discharge side we have the flexible connector, and again we have check wall and the gate wall. It is connected with the discharge header, and we have one special rule in the fire pump room piping that, for example, if you see here from this T to the suction set flange, so this distance must be, you have to follow 10 times of D. So this rule must be followed. So this is as per NFA 20. For example, in your suction side your piping is for example this is 200 mm for just for example. So you have to follow the rule that, so 200 mm into 10 times. So you have to provide 2 meters straight pipeline in the suction side. That means from this T flanges to the pump side suction flange. So this length must be 2 meter. The 10 into D rule you have to follow for the fire pumps. Okay, so and the next requirement is, now coming to the discharge header, all the suction side we have finished. So we have the, you can see the diesel pump which is connected with the discharge header, and also the jockey pump which is coming from bottom which is connected with the discharge header, and also the electric pump. So this line also connected with the discharge header. So all this discharge header line which is going to serve the system. So it will go like this, like to the underground, because this underground, from the underground which is going to serve to the 10 different buildings located far away. So this is called as a service building. From the service building the fire pump is located, and from here it is serving to different area. Normally for the residential and commercial area the fire pump room is located in the ground floor. So from there it will serve to top side, and in this project we have the common room because it's a very big project. From here it is serving to different areas. And in the discharge header the main thing is, like you can see this line, this is called as a test line. So testing line means we have the flow meter here. In the flow meter we have two isolation wall in the front and back side to isolate. If you want to do any maintenance in the flow meter, you can isolate this two wall and you can make the maintenance. So this testing line which is distributing further, which is connected with the two tanks like this. This will be connected with the two tank, and the important thing is, like for example, here in the section drawing you can see how many coordination you have to do with the civil team to provide proper opening, I mean the puddle flanges opening and all these things. For example, starting from here we have the suction pipe. We have two suction pipes shown in the image with the anti-vortex plate I have shown here, and additionally from the top you can see the TFL line. The TFL line means I told you tank filling line which is coming from the water supply. We have two tank filling line, and also we have discussed about the testing line. Testing line recently we discussed. We have the two testing line branches are there which is coming from the discharge header, and after that we have this line. This line is called as RLP. So RLP line, as I told you, it's a relief line pipe. So RLP relief line pipe we have indicator which is coming from the diesel pump. So there are two different branches for the relief line pipe, and also OFP. OFP is a overflow pipe. Overflow pipe we have to provide for the two tanks. So this is the OFP, overflow pipe, and we have here the vent pipe connection we have given. Additionally we have the drain connection. WP is a waste pipe drain connection we have given. So all this must be provided in the tank. So this will be properly coordinated with the civil team. So here additionally we need to see one more pipeline like you see in this color. So this is the diesel engine exhaust pipeline, and this arrangement is called as a muffler. So this diesel engine exhaust pipe will normally go to the outside for the termination, and in this diesel engine exhaust pipe we have to provide the installation also. Normally we provide the raw cool installation. For example, if you see in this section drawing, you can see at this point. So from the diesel engine we have this exhaust pipe which is going outside and which is going top, and which is terminating like this, terminating vent cap. So this line has to be provided only for the diesel engine. And coming to the next important arrangement, we are going to see this line, the different line which is going like this to the controller. So for the this is for the diesel pump, and coming to the jockey pump also we have this line, and also electric pump this line. So all these three lines which is going to different controller. This is for the individual pump controller. So we will see some extra details about this controller. So like you see in this section drawing, it is very clear that this line which is coming from the fire pumps and jacket pump, which is connected with the individual controller like this, and in each controller we have the PS, that is called as a pressure switch. And in this section drawing, you can see some additional requirement. First I will open NFA 20 requirement, then we will come to this one. So as per NFA 20, for example, this is the suction side of the pump, this is the discharge side which is going to the system. So this is the OS and Y gate wall, and we have the check wall here. So we must provide the sensing line in between these two wall, in between the OS and Y gate wall and check wall. We should not provide the wall, we should not provide the sensing line after the check wall. It should be always between these two wall. So from the sensing line, like you see here, we have to provide two check wall. So this is the first check wall and this is another check wall, and in between the two check wall, the distance must be not less than 5 feet. So minimum 5 feet distance should be there for the in between the two sensing line, and the sensing line which is going further to the controller, and controller must have the pressure switch. This is the control panel, and the control panel bottom side you can see some special requirement like you see here and here as well. So there should be two globe wall. This is the first globe wall, this is the second globe wall, and additionally here also two globe wall. Also we have a 1/4 inch or 6 mm plug, and this point also this point. So these are the special requirement for this system. Then coming to the pressure sensing line material, as per NFA 20, the pressure sensing line shall be brass material, or it should be rigid copper type KLM. So KLM is an American based one. If you go to the British one, you can see the X and Y. Based on the underground and above ground, we use the X and Y. Similar to that is the British standard. Coming to American standard, for the copper pipe we normally classify like type KLM. Based on the underground and above ground, the thickness also will change. And otherwise, you have to use series 300 stainless steel pipe or tube for the sensing line. And the fitting shall be minimum of like normally 15 mm nominal size. We will use the sensing line. We are not allowed to use the flexible copper. Normally that is what normally we are using for the DX split unit in our home. That type of copper is not allowed. Only the rigid copper is only allowed for the sensing line. So these three material you have to choose for the sensing line. So next to this line, suction and discharge, we clearly discussed. So going further, so this is the discharge header which is going to the serving to the pump room, like a different building. So here you can see one branches I have taken. So this line, this is the zone control wall line. So which is supplying to the this is for the sprinkler. You can see the different sprinkler I have shown here. Normally for this fire pump room, we normally provide the sprinkler. I will explain the reason for the factory mutual special requirement also now. So first going further, if you know that factory mutual FM or UL, there are different codes requirement the fire pump room or firefighting equipment has to satisfy, has to comply. So we have one special requirements like factory mutual. So factory mutual, like if you see there, don't use the pump room or pump house for storage purpose. That's a special requirement from FM. And provide automatic sprinklers over engine driven pump. So this is the special requirement from the factory mutual. We have to comply. So that's the reason normally we provide the sprinkler system for the fire pump room. So this one they clearly mention automatic sprinkler has to be provided over engine driven pump. So we have the engine driven pump here, diesel engine pump. So we are providing the automatic sprinkler. Provide suitable means for maintaining the temperature in the pump room above 5 degrees Celsius. So 5 degrees Celsius, minimum 5 degrees Celsius and above should be maintained for the fire pump room. Provide ventilation for the pump room and pump house. So we have to provide the mechanical ventilation for the fire pump room. So these are the special requirement we have to comply. And coming to the UL requirement for the fire pump, so you can see normally we are following UL 448 requirement for the fire pump. So we have to select the fire pump only from these 4 cases only. For example, I am using here the N-section top discharge pump. So this is the pump I am using for this project, and this would be like and this is normally used for the lower flow range. For the higher flow range, we have to use these two type of pump, whether it is a vertical turbine pump or split case pump I can select. And coming to the stages, that means the number of stages for the impellers. So it's a single and two, that means single impeller, double impeller which is connected in the series pattern. So coming to the split case, we can go with the multiple impellers, multi-type also is allowed to use there one. So this pump which I am using here is allowed to use for the motor or engine. That means I can use the same pump for the electric pump, I can use the same pump for the engine pump. Coming to the vertical inline, I am using the Jackie pump in this project. Normally we are using vertical inline Jackie pump. Jackie pump is not allowed to use like a diesel engine. It can be used only for the electrical device, not allowed for the diesel engine. So this device as per UL also we have to comply when we go for the selection of the fire pump. So in this fire pump room, I have provided the zone control wall for this fire sprinklers, and the maximum spacing, minimum spacing, as I mentioned the starting of the video. I have followed this requirement, maximum spacing and the production area and the sprinkler density, all this thing I have followed this special requirement. And moving further with the next one, you can see one more line which is connecting with this main header, which is coming from outside, so which is going further to the outside. So this line is the breaching inlet line, you can call fire department connection also. So the fire department connection I have provided here, and from here I have taken the line like this, and which is finally connecting with the discharge header line. So in regards to fire department connection, you have to understand few things. First of all, when this is the individual room, when you go for the overall layout, you have to make sure that the distance between the fire department connection to the fire engine area, this should not exceed the NFA requirement. And also this one, the spacing, for example, if you see here at this point, here I mentioned that fire department connection refers site plan drawing for hot standing location. Hot standing means fire engine standing location. So in the overall site plan, you have to coordinate when you provide the location for the building's fire department connection. The distance must not exceed the NFA requirement. And here, additionally, if you see the UAE fire and liability code, they have some special requirement like a breaching inlet shall be provided for the building active system. So a separate dedicated breaching inlet located within 18 meter of fire truck parking. So as I explained that from the breaching inlet to 18 meter, the fire truck, that location should be there, shall be provided directly to the, this point is very important, shall be provided directly to the fire water tank. So for the fire water tank, there should be a separate breaching inlet we have to provide. So this drawing which I explained here is based on the Qatar Civil Defense. So Qatar Civil Defense, their requirement is that in this drawing I have provided the breaching inlet like you see here. I have provided the breaching inlet directly connecting with the discharge side. Okay, so I'm coming to the UAE. So along with the requirement mentioned here, we have to follow some additional requirement also. Like they mentioned here, we have to provide the separate breaching inlet for the wet riser, sprinkler riser separately, and addition to the tank requirement also. The next one, coming to the diesel tank, you can see some special requirements. For example, the first line, like you see here, diesel tank supply line. The diesel tank supply line I have taken from bottom. We are providing one ball wall. So this supply line will give the diesel to the diesel tank. Coming to the return, so you can see the next one, return line with 15 mm. So this the blue color one, which is coming from the diesel tank, the return line, and the diesel tank vent pipe. So from the top of the diesel tank, I have taken the vent pipe. So this vent cap will be terminated at outside. Termination vent cap for the diesel tank. And the next one, like this one already we discussed, muffler for the exhaust pipe. This is coming from the diesel engine itself, which is terminated in the outside with the termination vent cap. And the diesel tank filling line, so from the outside the diesel tank has to be filled. So like you see this line, which is connecting with the top of the line. So this is the diesel tank filling line. So diesel tank filling line, supply line, and return line, and also vent pipe. This are the important thing we have to provide for the diesel tank. In addition to that one, we have to provide the bund wall. So you can see here there is a bund wall I have shown here. So bund wall normally we provide if there is any leakage in the diesel tank. This all the diesel will not go outside the fire pump room. This will be collected in the diesel bund wall itself. So we are providing the bund wall for the diesel tank. So you can see here this bund wall I have provided. So sizing of the bund wall and the fire pump room design, filling line sizing, all this requirement sizing of the fire pump room, I have provided a very detailed video in my page. So I have shared the link also in the description. So if you want to watch that one for the design, you can watch that one. So in addition to this one, now we discuss about the suction line, discharge line, all the accessories in the suction line, discharge line for the diesel pump, jacket pump, electric pump, and also sprinklers requirement, testing line, relief wall, filling line, and also this zone control wall, this corridor line, sensing line, controller. So we have discussed a very detailed discussion of this one. And finally we have to see one more thing, that is the spare cabinet. So as per NFA 13 and as per NFA 25, we have to provide the spare cabinet for the sprinkler system. So if you see the requirement here as per NFA 13 and 25, so for the sprinkler system, If you have the project with under 300 sprinkler, you have to provide minimum 6 sprinkler as a spare sprinkler, and if you have sprinkler with 300 to 1000, you have to provide 12 sprinkler minimum, and if you have more than 1000 sprinkler in your project, you have to provide no fewer than 24 sprinkler. So these are the different sprinkler you have to provide. In addition to that one, there is a special requirement, like if you have different sprinkler, like pendant sprinkler, you have the upright sprinkler, and you have the sidewall sprinkler. So if you have different type of sprinkler, this requirement has to comply to all the individual sprinklers. Okay, so that means if you have 300 pendant sprinkler, you have 300 upright sprinkler, you have 300 sidewall sprinkler, then you have to provide each sprinkler with not less than 6 sprinkler as a spare cabinet in the fire pump room. So I believe you have some, you got some clear understanding of the fire pump room. If you still have any further comments, please please add your comment in the comment section. In the next video, we will see one complete fire pump, complete firefighting project discussion with all the requirements, sprinkler requirements, fire hose cabinet, everything for the complete firefighting project. Okay, so thank you for watching the video. We will see you again with another interesting video. Bye bye.